Welcome back. Today, I am going to show you how to add an additional layer of security when you SSH into your server. Let's review everything we've done up to this point. I own a server somewhere on the internet. I want to access it remotely from a client PC. To do this, I use SSH, an encrypted communications protocol. The cryptographic secret key that authenticates my client, granting it access to the server, is not on the machine itself, but on an external security device, a Yubikey. To reach the server, I route all my internet traffic over the Tor network, encrypted. And the SSH service at the server is only reachable through a Tor hidden service version 3, whose onion address is non-discoverable. Now I am going to add another layer of public key cryptography to make our onion service private. Any client that wants to connect to my server will have to provide authentication credentials. This is called Client Authorization. I will create a new key pair. The secret key I will keep on my client. Every time I try logging in, the server will check its list of public keys from authorized clients. If my public key is not there, I won't be allowed in. And by the way, I am going to do this from Linux tails, which further increases the level of security and privacy. This might seem like a lot, but compared to what was going on in the old days of Telnet, where nobody encrypted their traffic, and there was no security whatsoever. I'm not saying that you should take every single one of these measures to access every single server that you set up, or have access to. But please be aware that there is a whole world of difference between this setup and ours. Use the right tools for the job, according to your specific threat model. Now that we're in Tails, I want to show you how to enable the persistent storage. I will be able to make some settings, software, and files available across different working sessions. So Tails is not that amnesic, if you so choose. All these persistent features will be stored on an encrypted volume in the free space left on the USB stick. So choose a strong passphrase. Please, take some time and learn about each aspect of the Tails operating system that you can add to your persistent storage. As you can see, the personal data folder is enabled by default. For our purposes, I will leave it that way. The packages that come pre-installed in Tails are vetted extensively for security. The Tail developers don't install anything they don't have to. So I will enable the additional software feature for being able to get what we need. I will also persist the GPG data directory, so I don't have to import my public key every time I boot Tails. Finally, I will enable the .files feature to persist config files situated at home. Notice that when you boot Tails, now you have the option of not exposing the persistent storage to your host computer's memory. I will type the password to unlock it, and will also enable the administration password in additional settings. Think of it as the ability to have sudo powers. First, I will connect to the internet. In Linux Tails, all traffic is routed over Tor by default. Let's look at all the features that I enabled in my persistent storage, one by one. First, the personal data folder. It is situated at home. There it is. So let's start using it. I have a backup of my password store, and my PGP public key, in a USB drive. I will insert it, and copy its contents to my persistent folder. Now, I will open a terminal window, in the .files folder. There, in the lower left. All files on this path are linked in the home folder using a symbolic link. So, if I want to persist a file there, I just copy it here, make the necessary changes, and save it. I will do that with the bash rc file, and append to it the command that we discussed on episode 2. TLDR. I will allow the GPG agent to receive requests from SSH. Let's now import our public key into the GPG data directory. It is already in our persistent folder. And finally, our password store. We need to install the package, pass. There's two ways of installing additional software in Tails, once the feature is enabled in the persistent storage. Using a graphical interface called the Synaptic Package Manager, or simply using the command apt from the command line. I will try both of them. First, let me install pass using the first method. Read that. Be patient while Tails downloads all the package indices from its repositories. It is doing it over Tor, and it might take a minute. If you get an error, you can try again, or just go ahead and search for the package you're interested in. You might get lucky. There it is. Pass requires the package tree to be installed. When you're finished marking packages for installation, click Apply, review what you're installing, and click Apply again. This is very important. You have to decide if you want to install these packages only once, for this session alone, or permanently, every time you start Tails with your persistent storage unlocked. Only do the latter, when dealing with software you really need, and that you're confident is not compromised. Now, I will reboot Tails, and check that all my persistent features work. I get a notification about new software being installed from my persistent storage. I will wait for it to complete, connect to the internet, and move on. Let's look at the bash rc file. The .files feature worked. There is a symbolic link to the file that we edited. Let's see if the line that we added is there. There it is. Now let's look at our GPG, public key ring. My public key is there. Don't forget to always trust your own keys. Everything is in place. I will restore my password store, get the address to my server's hidden service, and SSH into it. In Tails, all the internet traffic is routed over Tor. So I don't need the commands, torify, nor, torsocks, to SSH into a Tor hidden service. The Yubikey is flashing. And we are in. We really took a detour there. But Tails is so cool. I encourage you to learn about all the features in the persistent storage. Tails is one of the simplest, most effective tools there are, for improving privacy and security. If you use it right. Now we will learn to set up client authorization on a Tor hidden service. I have written a file with instructions to set up client authorization. Let's open it up and use it as reference. Three things we need to do. First, create a private public key pair. Second, set up our server for client authorization. And third, set up our client. So let's start with step 1. I will create the keys here, in Tails, my client machine. To do this, I need 2 packages. One of them is not installed by default in Linux Tails. So let's go get it. That's the one. Remember what I said earlier, about additional software. I only need this package to format a cryptographic key. This is a one-time operation only. So there is not reason for me to add this package into my persistent storage. So let's follow the instructions. First, let's create a private key. Format this key into base 32, and leave it on my desktop. This last line derives a public key from the private key, formats it in base 32, and leaves it on my desktop as well. It is a long command. Make sure you copy all of it. Also notice that the paths for the desktop specified in these last 2 lines will only work on Tails. If you're using another Linux distribution, please change it accordingly. I have the keys. Let's move on. In the second step, we set up the server for client authorization. It is very easy. Just write a file inside the authorized clients folder, and include your public key. You can name that file whatever you want, as long as it ends in .auth. I will name it SSH. Write your public key into the last field. And make sure that this file is only 1 line long. Save and exit. Print the file to screen, and make sure that it contains only 1 line. If you don't get this right, you might have issues later. Now let's make Tor service account be the owner of the file. The last step on the server side is to reload Tor. Reloading the process will not restart Tor. It will only read configuration files again, and apply any changes. If we did restart the process instead of reloading it, our SSH connection would end, since we are connected to a Tor hidden service. So ideally, we should try reloading it first, and if we find issues later, come back to this step and force a restart. To avoid any problem, I'll go straight to restarting Tor, and make sure this is going to absolutely work. And there you have it. Restarting the process has ended the SSH connection. As you might have guessed, I have done this because client authorization changes on the server usually do not work if you do not restart Tor. But please, don't do this unless you have other ways of accessing your server. You don't want to get locked out if you did something wrong. Third, and final step, of setting up client authorization. Now, I will configure my client. I need to have Tor installed. If you're not on Tails, watch the previous episode where I show how to do this correctly. So, first thing to do is to specify the folder where I will be storing my private key. I will write this line into the Tor configuration file. Now I need to create the folder that I just specified in the Tor configuration file. And a file which will contain your private key. You can name it however you like, as long as it ends in .auth_private. That file must contain the following single line. I will write my private key in the last field. In the first field, I must write the onion address of the hidden service I am accessing. But without the onion part. I will get it from my password store. Please remember that this file must contain 1 line only. I will print it to screen and make sure. And finally, let's change the ownership of this directory and file to Debian Tor. Now, restart Tor. And we're done. Everything is ready to test our first SSH connection with client authorization. My Yubikey is flashing. I'm touching it now. It worked. Now I will log out. And I will get rid of my secret key file by moving it out of its folder. If I do this, I won't be able to log into my server. I will have the SSH authenticating key, and I will be accessing the correct onion address from my hidden server. But I will be missing the credentials for client authentication. Let's try that. The connection is refused by the server. Let's put the secret key file back in its folder and try again. The Yubikey is flashing. Touching it now. It works again. Now I'm going to copy my keys into a USB drive. Log out. And try accessing my server from my regular Ubuntu. Okay. I'm in Ubuntu. I want to show you one more cool thing. But to do this, first I need to SSH into my server. I will set up this machine for SSH with client authorization, following the procedure that you already know. I won't pause. And I won't say a word. Let's see if you can follow along. Okay. I am in. Let's leave this SSH connection open for now and go to another terminal window. Right now, the server that I'm accessing is on my local network. I'm going to SSH into it, the same way we did in episode 2. Right. Now I have two SSH opened connections to the server. One through my hidden service, over Tor. And another through my local network. Now let's open the SSH configuration file. Take a look at this line. Imagine that I want the SSH process to listen only to requests over Tor. I could easily do that by typing the address of my local host. Restart SSH. Let's test it. I will log out and try logging back in. I cannot. Let's log out now from the other SSH connection, and try logging back in, through the Onion service. I can SSH. Only over Tor. Pretty neat, huh? So now you have a decent understanding about how to safely access a remote server. It's been fun, and I really hope to see you again soon. And remember, do your own research, and learn about other tools that can help you harden your server. Bye bye.